We've seen over the past few lessons how features are often separated as entities in their own right. Now, feature servers are still SIP servers, understanding the rules of SIP, how to receive and process requests and responses, how to interpret SIP headers, parameters and payload, and how to do all the other core things SIP servers do, like routing, reliable delivery, error handling, and so on. So, if I want to build a new feature, I first have to learn the low-level intricacies of SIP and then build my base SIP server functionality before I can even start adding my own custom functionality. There's much I have to do just to get a base SIP server that I can then build on top of. Wouldn't it be nice if there was a framework that gave me all that low-level SIP stuff so I can focus on my custom functionality and business logic? You've guessed it, there is. It's the SIP application server. In this lesson, we'll introduce the SIP application server, and we'll see how it's a framework through which new custom applications, new features can be developed without first having to learn about and build base SIP server functionality. So, the SIP application server comes pre-built with the ability to receive and pass requests and responses, to interpret message content, to route messages, to send them reliably, to handle errors, and a whole lot more. It doesn't have any business logic, and by default makes no decisions about what to do or when to do it. But it does have space for applications, essentially sets of instructions that tell the application server what to do with each SIP message. In fact, the application server exposes an application programming interface, the SIP Servlet API, a set of tools through which it notifies my application when a SIP message arrives, gives me the ability to pass and manipulate the content of SIP messages, and provides me means through which I can determine how the call is handled. The API is a published standard, meaning that SIP applications are portable between different SIP AS implementations. Now, if I want to build a new feature, all I have to do is learn the API and then use it to add my custom functionality and logic. Easy. I've got to tell you, I'm a big fan of the SIP Servlet API and the SIP AS, having spent a good few years teaching application development on the SIP AS. Now, imagine I'm tasked with building a simple call barring application that denies international calls. The business logic is simple. On receipt of a request, we check the dialed address, and if an international number, we reject it. Otherwise, we allow the request to continue. So, how would the code look? The SIP Servlet API expects me to include a doRequest type method in my code, public void doRequest, set up to receive a SIP request. Then, when a request arrives, the application server invokes my application, passes the request to its doRequest method, and executes any instructions. So, to bar forbidden calls, first, to get the dialed URI, I take the request given me by the server and use its getRequestURI, a tool from the SIP Servlet API toolbox that gives me back just the request URI from the request start line. To get just the dialed number, I take the dialed URI and call getUser, another API tool, this one to get back just the username part of the address that contains the dialed number. Then, if the dialed number matches a forbidden number pattern, we use another request method, the createResponse tool, that instructs the server to create a SIP response of type 403 forbidden. Then, on that new response, we call send, the instruction to the server to send it out upstream back to the caller. That's all we need to do to receive a request, check it, and if desired, reject it. If the dialed number's not forbidden, we use another API tool from the request, the getProxy method, through which we get a proxying tool and straight away call its proxy2 method, the instruction to the server to send the request. Easy. Of course, this is a very simple app and most will be much more complex, but it gives a feel for what it is to create features. We still have to learn the API, but it's a good deal easier than building SIP servers from scratch. I think of SIP-AS applications as pluggable components that we upload and deploy on the application server. Then, as I said, when a request arrives, the application server invokes the application and executes all the application's instructions that tell it what to do. The SIP Servlet API toolbox provides all the tools needed to receive requests and responses, to parse and analyze message content, including headers and message payload, add content to messages, including headers and payload, route requests to custom destinations, build new requests, use timers, handle forking, state management, and so on. It's a really comprehensive set of tools that greatly simplifies application development. In fact, thinking about all the different SIP servers we've discussed so far, well, there's no reason why they couldn't have been created as applications on an application server using the SIP Servlet API. Take the registrar, for example. On receipt of a register request, we simply parse the from and to headers to check the user performing the registration and the address of record being registered. And if OK, we parse the contact header for the phone's current IP address, and we write the contact address and the address of record to the registry, probably using JDBC and a database. We also check the expires header and prepare to remove the registration at the end of the expires period. Easy. So in summary, the SIP application server is a platform for custom application and feature development. It comes preloaded to receive and manipulate SIP messages, but with no business logic. The logic's defined in applications. Receiving a request, the SIP-AS invokes the application and executes its instructions. Applications are written using the SIP Servlet API, a set of tools through which the application interacts with and instructs the application server. Although application servers are often used for creating features, they could also be used to build regular SIP services like the registrar location and redirection servers, and even session management servers. If you'd like to know more about application development on the SIP-AS, feel free to get in touch.